All right, this is the second half of our 7.3 notes. So there's a separate video for the first couple problems that we did. So again, this would be the back side of the 7.3 notes. These two problems are a little bit different because they have radicals in them. So I just wanted to make sure that everybody was okay understanding it with radicals. It's the same process though. The directions have changed slightly. They just say that angles A and B are both in quadrant 1, which again just means that you can draw the exact same triangles that we've been drawing. So I'll draw triangle A right here and B. And then I'll label my sides. O, A, and H. O, A, and H. And then we can actually put the values that they give us onto our triangle. So here they tell us that cosine of A is the square root of 21 over 5. Cosine is A over H. So on my first triangle, my top triangle A, I'm going to go ahead and put square root of 21 on the A side, on the adjacent side, and 5 on the hypotenuse side. And then I'll do the same thing for B. Cosine of B is 7 over 10. So again, they're giving me cosine A over H. I'll put 7 on the A side and 10 on the H side. All right, so we talked in the earlier video on the front page about the Pythagorean triples on your unit circle. So you have these triples. However, none of these triples have any square roots in them. So as I look at triangle A and I see the square root of 21, I know that I'm not going to be able to use that Pythagorean triples list. So I'm going to have to come off to the side and just do the Pythagorean theorem. A squared plus square root of 21 squared equals 5 squared. All right, a square root and a square are opposites, so they cancel out, leaving me just 21. 5 squared is 25. And then you could subtract 21 from both sides to get 4, and square root that to get 2. So that missing side here would be 2. All right, let's do the same thing for this bottom one here. 7 and 10 are both whole numbers, so I'm just going to quickly check my Pythagorean triples list. I don't see any of them that have a 7 and a 10, not at least in the same pair. I see the 7 and a 10, but those are kind of different, so I'm not going to be able to use the list for that either. I'll have to do Pythagorean theorem again. So I'll come down here in the space that I have and do a squared plus 7 squared equals 10 squared. Seven squared is 49. 10 squared is 100. And then subtract 49 from both sides to get 51. I'll square root that. That is not a perfect square, so I actually want to leave the answer as the square root of 51. I do not want to turn it into a decimal. All right, so now I've got my two triangles completely filled in. I know all 3 sides. I'm ready to go ahead and start writing the equation from the back of the unit circle. So I want to copy down the one that says the cosine of A plus B. On the back, cosine of A plus B, here it is. I'm going to write down all of that. Noticing again that the sign is different in the middle. I have a plus versus a minus, so just be really careful with that as you copy it down. All right, noticing again that you have all cosines and sines here. So that's going to be my next step. I'm just going to go ahead and for each of my triangles, find sine and cosine. Sine of B and cosine of B. Excuse me. Sine of A. So looking at the first triangle, the top triangle, sine is O over H. So 2 over 5. Cosine of A is A over H. So the square root of 21 over 5. Now I shift my focus to the second triangle. Sine of B, O over H again, square root of 51 over 10. And cosine of B, A over H, 7 over 10. And then we take those 4 answers and we just carefully put them into the positions where we need them. So first thing it asks for is the cosine of A. Here's the cosine of A. Square root of 21 over 5. All right, then it asks for the cosine of B. So cosine of B is going to be right here. 7 over 10. Next, it asks for the sine of A, right here, 2/5. And then it asks for the sine of B, square root of 51 over 10. All right, and then from here, we're going to do the same thing. You're still going to multiply the 2 sections together. The only difference is when you're multiplying, if both things are not a square root, you can't actually multiply the number together. You're just going to write it next to each other. So when I look at this chunk right here, I end up getting 7 square root of 21. All right, not actually multiplying 7 times 21 in my calculator, putting the 7 in front, and the 21 stays inside the radical. And then 5 times 10 is 50. Same thing over here. I'll write 2 square root of 51. 5 times 10 is 50. If and only if the square roots match, right? So the 21 and the 51, if those were the same number, I could combine those as like terms. Since they're not, I have to leave them as 2 separate terms, like that. But since I have common denominators of 50, I'll put the whole thing over 50. And that's going to be my final answer. It's not pretty, but it is correct. All right, let's take a look at the next one. Example 4. Again, we have another radical here. So we'll start by making triangle A, triangle B, and again, this is a good chance for you to pause this video here, see if you can do as much of it as you can, and when you get stuck, you can kind of play it fast forward as best you need. I'll label O, A, and H. And I'll put it on as O over H and O over A. So tangent on this one, O over A. Just make sure you get those letters correct. And I'll put my square root of 57 and my 8 on here at the bottom. On my first triangle, I have a 2 and a 3. So those are both whole numbers. I'll go ahead and quickly check my Pythagorean triples list. See if I have anything with a 2 and a 3 in the first, 2 in the first, one of the first 2 places and a 3 at the end. I don't see anything like that. That means I'll have to do the Pythagorean theorem. So a squared plus 2 squared, and your hypotenuse always goes in for the C value at the end. And since I did not get a perfect square, I'll go ahead and leave it as the square root of 5. Triangle A is all ready to go. Let's finish up triangle B. Now here, be careful because this is you're missing the hypotenuse. So when you set up the Pythagorean theorem as a squared plus b squared equals c squared, It's the c squared that we don't know. So I'm actually going to type it in as 8 squared plus the square root of 57 squared equals c squared, right? You don't know your hypotenuse. Square root and square cancel out. Add those together. And square root and 121 is a perfect square, so we get 11. That's nice. Once you have all three sides of the triangle, it's time to kind of move on to your sign of a plus b, this right here. So from the back of your unit circle, copy down the formula. And again, we can see that all we need is the cosine and sine of each problem. So for our first triangle A, the sine is O over H. The cosine is A over H. See if you can get the sine and cosine for the B triangle. Sine of B should be square root of 57 over 11. And cosine of B should be 8 over 11. And now that you have these four things right here, we're just going to kind of put them in the correct places into our formula. So sine of A, 2/3. Cosine of B, look over here on the left, 8 over 11. Cosine of A, come over to the left side. Just write it down. You've already done the work to set up the answers. Now you're just putting everything in the correct place. Right. We'll go ahead and chunk those together. We'll multiply first. 2 times 8, 16. 3 times 11, 33. All right, now here we have two square roots, two radicals. Because they're both inside the radical bar, we're going to multiply those two numbers together. So 5 times 57, and the answer would be 285 inside the square root bar. And 3 times 11, 33 again. Now, you won't be able to really combine 16 and the 285 radical, but since you have 33 as a common denominator, you can at least write it as one big answer. There we go.